Good morning, student. Let's start today's class. Today we are going to discuss about congestion. Okay, congestion. Okay, congestion means we always told that in bus there is congestion. Congestion means a lot of load or a lot of people or a lot of heavy load. Okay, in network case the congestion means that it is an issue. Okay, an important issue in a packet switch network is congestion. Okay, congestion in a network may occur if load on the network. Okay, load on the network, the number of packets sent to the network. The load of network means the number of packet sent to the network is greater than the capacity of the network. That means whenever the number of packets or the number of message frames, okay, is greater than the capacity of the network, or capacity of the network to handle it, then the this congestion problem is occurring. Okay, so that means congestion is the problem which occur when the incoming frames or in the packets which we want to send through transmission line is greater than the channel capacity of channel. Okay, let's say capacity of channel is carrying three packets simultaneously, but in the sender want to send five packets, or there is a five packets to send through the channel. So in this case there is a congestion happened. Okay, in the input side. Okay, input side of the channel. Okay, then uh, to handle it, congestion control refer to the mechanism and technique to control the congestion and keep the load below the capacity. Okay, this is the concept behind the congestion control. Okay, now you may ask why there is a congestion in a network. This is the question this is the question arise in your mind. Okay, so congestion happened in any system that involve waiting. Okay, for example, congestion happened on a freeway because any in the flow abnormality in the flow, such as accident during rush hour or create blockage. Okay, then congestion in a network or internetwork occurs because routers and switch have queues. Okay, this congestion problem is happened due to the router or the switches have queues, buffer. Okay, that hold the packets before and after processing. Okay, a router, for example, has an input queue. Okay, and a output queue for each interface. Okay, when a packet arrived at the incoming interface, it undergoes three steps. Okay, before the departing. Okay, here you see this is a router queuing example. Okay, this is the router. Okay, here the interface, one interface is there, one interface is there. Okay, this is here also one interface there are three interface. This router routing the, let's say, from this information, this interface to this interface. Okay, or this interface to this interface, or this interface to this interface. Okay, this is the function of router. But here what happened, every interface have one input queue, one, and this is input queue, and this is output queue. Okay, one this is called buffer or queue, or a fixed memory allocated for the input and output. Okay, this is the queue. Okay, let's say we send four packets. Okay, let's say we send four packets. Okay, here four packets. So the four packets entering inside the queue. Okay, and waiting for the processing. Okay, then whenever, let's say, this queue is full. Okay, or uh, one place is vacant. Okay, so this four packet, okay, uh, or these 4 packet placed inside and waiting for their turn. When this information coming to the front of this buffer, then this interface or this routing process this uh, this packet. Okay, so for this time or the for this remaining or for this timings, okay, this information, okay, wait here and queuing one by one. Okay, that means one in packet, one packet, one packet, okay. This queuing happened here and also queuing happened in the output as like as input. Okay, so for this queuing process this congestion happened. Okay, this is the end. These 3 steps, which steps is that the packet is put at the end of the input queuing. Okay, this end of the input queuing. Okay, while waiting to be checked. Okay, then the processing module of the router remove the packets from the input queuing once it reach the front of the queuing and use it routing table and destination address to find the route. Okay, then the packets in input then the packets is put in the appropriate queue, appropriate output queue, and wait its turn to be sent. Okay, we need to these 3 steps happened in the router of the queuing, or these three process is done in the routing process. Okay, now we need to aware of two issue. First, if the rate of packet rate of packet arrival is the higher than the packet processing rate, the input queue became longer, okay, and longer. Okay, this is the one issue. Okay, if the rate of packet arrival is higher than the packet rate processing rate, let's say the packet is the packet rate incoming packet rate is, this is the router, let's say this is the router. Okay, incoming packet rate is 5 packet per minute. Okay, this is the input rate. Okay, but the processing rate of this router is 2 packets per minute. So since the the processing speed is less than the incoming packet rate, so here the input queuing, okay, there is a congestion happened. That means the number of packets wait for their processing process. Okay, so due to this issue, congestion will happen. Okay, next issue is the second, if the packet depart rate is less than the packet processing rate. Okay, that means you see, if this is the router, okay, the processing unit, let's say 2 packets per minute. Okay, but in the outgoing, okay, for the outgoing, the rate is 1 packet per minute. Since this outgoing uh, rate is less than the processing rate, here also, uh, here in the inside the router, the store of information happened or queuing of information happened. So here also congestion happened. Due to these two problems, congestion happened. Okay, then now you know what is congestion, okay, and how this congestion happened. Okay, now the effect of congestion we read in coming classes. Okay, thank you.